Hello everyone, welcome back to Algebra 1 with Miss Betsy. Today we are going to be talking about dividing integers. The text that I'm using is Algebra 1 for Christian Schools. It's published by Bob Jones University Press, and I'm using the second edition. If you want to track along with me, you have to use that exact edition. If you're just trying to figure out how do I divide integers and watch the video without a book, you don't need it. But just be aware that this lecture does not track with the third edition of Algebra 1 for Christian Schools by Bob Jones University Press. They've moved the order of things around. You could find something in your text and look up dividing integers, but it's not going to be the same section number that we're studying, which is section 1.6, beginning on page 23. So let's go ahead and pray. Lord, once again, we come to you so grateful for who you are and so much in awe of your majesty. Father, I ask that you would give to us the ability to understand the material that you've given to us to learn today. Help me to communicate and help my students, every single one of them, to be able to grasp the concepts and to apply them as necessary. And I thank you for that in Jesus' name. Amen. Okay, my lame joke for today. I've got a list here of ones that I'm trying to keep track of what I'm using, and I think I'm going to use this one. What does a robot frog say? And we have robot dogs, we have robot vacuum cleaners. Well, a robot frog says, ribbot, ribbot, ribbot. So, pretty lame, but the more lame that it is, the better. Okay, what we're going to do is talk about dividing integers, and we know how to divide whole numbers, we know how to divide natural numbers, we know how to divide numbers that are positive. When we add in that division of integers, we're having to deal with what happens when we have a negative number that's involved somehow in our division problem. In our last section we talked about what do we do when what happens when we multiply positive and negative numbers together. And we saw, of course, that if you multiply two positive numbers together, your product is always going to be positive. And we learned that also, if you had two negative factors that you multiplied together, your answer or your product was still going to be positive. But when you had one positive factor and one negative factor, no matter which order those positive and negative numbers occurred, your product was negative. And we learned a while ago about inverse operations. Inverse operations are operations that undo one another. It's sort of like if you have a jacket with a zipper. Your zipper functions as an inverse type thing. Put your jacket on, you pull the zipper up, and you're snug in your jacket. The inverse is to take the zipper down, and you're now back to what your jacket looked like. You put it on and it's open, you zip it up, you zip it down. The up and down, they function as inverse operations. Addition and subtraction are inverse operations. If we start with $10, and then I add $2 to it. I would do this in class and say, hey, here, you've got $10, let me give you $2 here. Well, now you have $12. But let's take that $12 that you now have and subtract, or I take my $2 back, and what do you end up with? You end up with the same $10 that you started with. So addition, and look at that, I slashed a 2 to make it a Z. Sorry about that. Addition and subtraction are inverses. Those are operations that undo one another. And you have that same thing going on with multiplication and division. They undo one another. So what that means in actual practice is that the same type of sign rules that you have for the multiplication of positive and negative numbers, with the answer being a positive number or a negative number, those are similar with division because You know, I am going to go ahead and revert to the book here, and this can be a little bit confusing. Matter of fact, in all honesty, it can be a lot confusing trying to figure exactly out what they're showing here, but you will very quickly learn what happens when you divide positive and negative numbers. What they're reminding us of is that every division problem, because they're inverses, they have two multiplication problems associated with it. It says, okay, if we have let me see, do I really want to do it this way? Let me show you multiplication one that they have here. They have the problem here where we have a negative 5 times a positive 3. That gives us a negative 15. We have one positive and we want to have one negative. This is our multiplication. Division is the inverse. It undoes it. So a multiplication problem is going to always have multiplication problem has two possible divisions associated with it. You can say negative 15 divided by a negative 5, and that's going to be equal to this positive 3. Negative 15 divided by negative 5 is a positive 3. Or you have negative 15 divided by 3 gives us a negative 5. You have only two separate ways that you can divide. You can divide when you have multiplied together to get a product. You take that product and you divide it by one of the factors. The product of negative 15 divided by one of the factors gives you the other factor. The product of negative 15 over here divided by the other factor gives you the remaining factor. You have a multiplication problem. The inverse is a division problem. And you have a choice of two different division problems. It's always going to be that product, and you're going to divide it by one of the factors. 15 divided by a positive 3, it's going to be the remaining factor. Negative 5, because negative 5 times a positive 3 gives us a negative 15. Okay? We take the product and we're going to divide it by one of the factors. Take the product, divide it by one of the factors. Over here I've divided it by 3. The result is a negative 5. Now I want to take this product of negative 15 and divide by a negative 5. Your answer is the remaining factor, which is a 3. Okay, what they're going to do is give you some examples here for your rules for dividing integer, and it talks about divisor, dividend, and quotient. And in my experience, if I were to ask how many of you know what dividend, divisor, and quotient are, maybe every single one of you would raise your hand. It's not likely, but amongst those of you who raised your hands, there's going to be some confusion as to what is dividend, what is divisor, and what is quotient. This is once more math vocabulary. So I'm just going to write this down for you. Copy this into your notes. dividend quotient is the answer to a division problem. Let me see if they've done this. Division can be indicated with this division bar. It can be with this division sign. Can have our fraction bar here. You can also say dividend divided by divisor equals quotient. Okay, quotient is the answer to a division problem. The divisor is what you are dividing by. The dividend is what you are dividing. Put this back into our elementary school arithmetic. The dividend is the whole group of M&Ms. The divisor is how many groups you have to divide it into. Okay? And I'm sort of feel like I'm slogging through some really sticky molasses mud type stuff right now with this vocabulary. Make sure that you know what the quotient is, make sure you know what dividend is, and make sure you know what divisor is. And then you can look at the bottom of page 23, and it tells you if the dividend and the divisor are the same, have the same sign, then the quotient is going to be positive. Dividend and divisor are the same. This is the first condition. Dividend and divisor have the same sign. Quotient is positive. And you can check this by multiplying it out. Let's do an example here. Dividend and divisor have the same sign. 15 divided by 3. They're both positive. The quotient, or the answer, has to be positive. Obviously, 15 divided by 3, 5 times 3 is a positive 15. So that's obvious. Well, what happens if the dividend and the divisor are both negative? If we want to say a negative 15 divided by a negative 3. Our quotient, our answer, has to be positive because of the connection between multiplication and division. We're going to follow this rule here, but we know that it makes sense because when we multiply, remember your long division rules, you multiply this times this, you have to get that back. How's that for good technical vocabulary? 5 times a negative 3, whatever we multiply, whatever number we put up on top of that negative 15, when we multiply it by a negative 3, we have to come up with a negative 15. And the only way that works is for the quotient to be positive. So as long as the dividend, which is the number that is being divided, and the divisor have the same sign, whether it's positive or negative, your quotient or your answer is always going to be positive. And I bet you can figure out what the next rule is here before I even write it. If the dividend and divisor have different signs, or unlike. Now this is not like when you unlike something on Facebook. Unlike here means different. The dividend and divisor have unlike signs. The quotient will be negative, always. Okay? So just be careful when you're working with division of signed numbers. Make sure you multiply it back, and that will verify for you that you have the correct answer. Now there's one more thing that they point out in this chapter, and is the difference between dividing 0 by a number and dividing by 0. You start out with nothing. And we're going to divide that nothing up into 18 separate groups. Well, how much does every one of those 18 groups have in it? Well, it has nothing, okay? Doesn't matter how many groups you divide 0 into, you still have nothing. You cut up nothing and you have nothing. Unless you're God, and then He creates the world out of nothing. He speaks and the world comes into existence out of nothing. It's the only time you're going to get nothing out of nothing, okay? But in arithmetic, 0 divided by whatever number is always equal to 0. So that would be, let's see if they actually show you that. 0 divided by a is always going to be 0, but they don't show you that. Now, however, let's say that we have 18, and we're going to divide that into 0 groups. Well, I know that if I want to divide 18 into one group, I'm going to eat it all myself. Then I've got 18 pieces of broccoli instead of 18 cookies or something. Or if I have 18 Hershey Kisses, and I'm going to split it amongst 3 people, 18 divided by 3 is 6. Each one of us gets 6. Or we divide it into 2 groups, something divided into 2 groups. You divide 18 chores between 2 people, each of you do 9 chores. But how do you divide 18 among 0? I really don't know what to do. Okay, it doesn't divide it into 0 because you've still got those 18 chores. So 18 divided by 0 is not 0, but we really don't know what it is. So in math, we say that that is undefined. And it is essential. If we ask you, what is the answer when we're dividing something by 0, you say that the answer is undefined. So this statement here says that division by 0 and see, I slashed that. Z, undefined. Make sure that you've got that down. So now that's one more property. You've got the commutative property of addition and multiplication. You have the associative property of division and addition and multiplication. You have the identity property for addition. That's to add 0. You have the identity property of multiplication, which is to multiply by 1. You have inverse operations, which tell us that a number plus its opposite is always equal to 0. You have the anytime that you multiply anything by 0, you're always going to get 0. And you have the distributive property. You also learn that division by 0 is undefined, but 0 divided by any number is always equal to 0. So make sure that you've got your properties down. Make sure that you can divide by positive and negative numbers. Send me a text if you're having difficulty, or talk to me when we meet face to face, and I'll see you next video.